So mark your own. Good old Ann Serkey. How much work is done if we ignore friction? I said, well, work equals force times distance. So it looks like this is going to be straight plug and chug. 767 times 28. 767 times 28 is going to be your calculator. Continue the trial version. Eventually I'll pay for this, but not yet. Do you get 21,500? No, yes? Units? Joules. Suppose they complete this task in 58 seconds. One mark for each of these. How much power will they generate? Power, Hannah, is work over time. So it's going to be my answer button divided by 58. Divided by 58. And I get 370 watts. About a half a horsepower, give or take. How much work is done by a forklift raising or lifting? Okay, I think this is going to be MGH. It's going to be 688 times 9.8 times 2.8. And I get 18,900. Joules of work. And then power, same question as number one, really. Same idea. Work over time. It's going to be my answer button divided by 73. And I get 259, I think, watts. Is work a vector or a scalar? It's a scalar. Work is measured in what units? Joules. Power is measured in what units? Watts. By the way, work is also measured in Newton meters, since it's force times distance. So if you had said that, I would accept that. And power is also measured in joules per second, since it's work over time. If you had said that, I would accept that. What's the minimum? Okay, they want me to find power. That's going to be work over time. And I think since we're doing stairs, it's going to be MGH over time. The time is definitely 83 seconds. The mass is 64, G 9.8. And I guess the height is 82 stairs times 0.21. 64 times 9.8 times 82 times 0.21 divided by 83. You'll get 130 watts. Next page. Power is work over time. I guess we're lifting. I don't think I need, or do I need the 24? Yeah, I do. It's going to be MGH over time. So it's going to be 25 times 9.8 times 24 all over 32. This has been kind of repetitive, Mr. Dewick. I get 183.75, 184 watts. Is that right? How efficient is the motor? So efficiency is going to be the smaller number. I'm going to use my answer button there, divided by the bigger number times 100 to make it a percent. So this divided by 244 times 100 to make it a percent. And I get 75.3. It's going to say almost certainly an electric motor. Yep, it's an electric motor. Okay, now I got to slow down a little bit. They want the work done by the applied force. I think the work done by the applied force is going to be the applied force times distance. Well, that I know. It's going to be 65 times 14. Okay. 65 times 14. 910 joules of work. How much work does friction do? Well, the work done by friction is going to be the force of friction times distance. I don't know the force of friction. I guess this is a job for a free body diagram. I have mg, normal force. I have F applied. I have friction. So this is going to end up being mu times the normal force times distance. I don't know the normal force. Oh, but look, another force the same size as the normal force. So it's going to be 0.25 times 12 times 9.8 times 14. I get 411.6. Is that correct? No, of course it can't be. Has to be wrong. Work done by friction is negative 411.6, since it's in the opposite direction of the motion. If you missed the negative, I would take a half mark off. What's the net work done on this mass? The net work is 910 joules minus 411.6. 910 joules. No, not plus, Mr. Dewick, minus. And I get 498.4 joules of work. I went really fast because I want to try and give you as much time as I can to work on the homework, but we'll see. Can you give yourself a lovely score, please, out of, what's this, out of 13?